Hello, this is Mr. Bedford, and in this video I want to look at how I use algebra to prove this cab2africa method. And this is for when we're trying to find the nth term of a quadratic sequence. Up at the top of my screen I have this ax squared plus this bx plus this c. So that there becomes just my general quadratic expression, if you like. So it's the general form for any type of quadratic. Now I'm going to make up a quick sequence for this one, and like I showed you in the previous video on the nth term, to make up the sequence we just say what happens when x is equal to 1, when x is equal to 2, when x is equal to 3, and so on. So let's have a look what happens for that side of things. So when x is equal to 1, I have a, and instead of the x squared, I put my 1 squared in there, and I have my b, instead of my x, I replace that with the 1, and I have the c. And there's no x's there, so it just stays as is. In other words, if I simplify that, I'm left with a plus b plus c. Let's have a look at my next term. When x is equal to 2, I have a, replace the x with a 2, and then I have my b, replace the x with a 2, and then I have my c. Simplify that, and let me just whiz through the rest. Now I need to find my differences between my terms. So this is what I was looking at on the first difference when I was doing the quadratic sequence nth term other video. So let's have a look here. To go from a up to 4a, I have to add 3a on. To go from a positive b up to a positive 2b, I have to add b on. And finally, to go from c to c, there's no change there, so nothing needs to be added to that term. Let's have a look for the next ones. Now I'm trying my best to make this as neat as possible. Again, 4a to 9a. So to go from that one now to the 9a, I've had to add 5a. To go from this 2b now up to a positive 3b, I've had to add 1b onto that, or just b. And similar again to go from the c here to the c here, no changes there. Next difference, 9a to 16a, that's a gap of 7a. 3b up to 4b, again a b, and no changes for the c terms. And then from 16a up to 25a, I've had to add on to that 9a. To go from 4b to 5b, I've had to add on to that b, and no changes for the c terms. I now look at finding my second differences. So that's from there to there. To go from the 3a up to the 5a, I've had to add on a 2a for that. To go from a b up to a b, I've not had to change the b, so nothing to add on to there. From a 5a to a 7a, I add on 2a, and no changes for the b values. And finally, from the 7a plus b up to the 9a plus b, I've also had to add on a 2a. Now then, in the MBMechMaths video, they use this value of 2a, this 3a plus b, and this a plus b plus c. What I find is that that's difficult to remember off the top of my head, and so what I like to do is work out the previous terms. And if I do that, I know that all of these are staying as 2a, so that becomes 2a. I guess I'm kind of working backwards here, so I could do the 3a plus b, take away the 2a, just leaves me a plus b, or if you like, a plus 2a makes the 3a, and the b remains unchanged. And working backwards again, I could do a plus b plus c, take away this in brackets a plus b if you like, which will leave me with just a c. Or c plus a plus b makes the a plus b plus c. And it's these terms which form my cab2africa idea. So that's why in our previous video I jumped straight in and said forget about the algebra, that's the bit you need to know. Okay, hopefully that's proved where that's come from. Thank you.